Hey everyone, welcome to SingularityComputers Client Build 13. This is going to be a high-end water-cooled build built into the Corsair Carbide Air 540. It's going to involve modding, including custom paint, airbrushing, and custom cables. Now this is actually the first high-end AMD build I've done since before I started my channel. This is not really going to be a themed build, but the color scheme is going to be purple, silver, and black, and the custom paint is going to involve lightning. So as always, I'm now going to get started with a brief overview of the components. So as you can see, I've started stripping down the Corsair 540 ready for custom paint. So I have the Asus Corsair 5 Formula Z, the AMD FX 8350, 32GB of Corsair Vengeance Pro, two Samsung 840 series 250GB SSDs, a Western Digital Red 2TB hard drive, and a Silverstone Strata Gold 1200 watt power supply, which I'm actually going to swap for the Seasonic X1250. For the water cooling components, I have the BitsPower DDC Top Upgrade Kit 250, the acrylic version. I have all EK water blocks for the CPU, motherboard, memory, and graphics cards. I have a Mod My Toys fan splitter, two bottles of Mayhem's Pastel Raspberry Purple coolant, and a Swiftech MCP35X. Now this is not actually all of the components. We'll take a look at the rest of the components as they arrive, and I'm going to give you a more detailed look at some of the components as I'm installing them. So the first thing I've done to start this build is strip down the case. I'm not actually going to be doing any case mods for this build, so I just need to focus on the custom paint. It was an easy case to disassemble. It's mostly screwed together, and it took minutes to disassemble this case, so it makes it an easy case to mod. A lot of cases are held together with a bunch of terrible plastic clips which break really easily, so it just shows the quality of this case. This is obviously the inner steel frame. I'll also be painting this, but I'm going to leave that until last. I'm going to paint the outer plastic panels first because it's mostly the plastic panels that I'm going to have airbrushed. I'm going to have a number of these panels airbrushed, and also the rear side panel of the case. So this is all of the plastic panels from the case except for the ventilated areas. The paint I'm using is an acrylic lacquer, and I'm now spraying the panels with top coat. I'm using two different colors, a metallic shadow silver and a metallic blueberry purple. I'm mostly going to use the shadow silver. I'm just going to use the blueberry purple as an accent because it is a fairly vibrant color and I don't want it to take from the airbrushing. Because I'm using metallics, afterwards I'll spray everything with a clear coat. I've completed the top coat, so the panels are now ready to be airbrushed. I'm really happy with the way the colors have turned out. You can see that the silver is a fairly dark silver. There's a fair bit of black in it. The purple is also a dark color, so it matches up with the silver, and the metallic ties the two colors in together. The purple is also a vibrant color, so it works well as an accent, and I'm actually going to use the purple as an accent throughout the build. There will also be purple in the lightning, and I'm definitely going to use purple coolant, which I'll dye to the exact color, and I'm considering painting some of the internal components purple and possibly even using purple sleeving in combination with black sleeving, but I'll only do this if I can get the exact color. Now you've probably noticed that I've already sprayed these panels with clear coat, and the reason I've done this before the airbrushing is because only a few of the panels are actually going to be airbrushed, and I decided that the painter who is doing the airbrushing can clear coat those panels again afterwards, and that way when the panels come back all of the painting will be done and I can immediately assemble the case and start the build. I'm also really happy with the way the finish has turned out. You can see that it's a high gloss finish. It does have a little bit of orange peel here and there, but that will certainly come out when I buff the panels. So you can see I've only used the purple on the ventilated sections, and I've even used the shadow silver on the mesh. So the purple will only cover a very small surface area of the case. At this point I've completed all of the painting, so I've also painted the inner steel panels of the case, and you can see that to paint these panels I completely disassembled the case. This part of the case is riveted together, so I had to drill out all of the rivets And it seems like a lot of effort to go to paint the case, but as I've mentioned previously, this way you can get better coverage and a better quality finish. It is possible to paint a case fully assembled, but you're not going to get full coverage. And something that I find happens, and this is avoidable to some extent, when you paint in an extremely confined space, because of the air turbulence, the paint keeps flying around until it dries, and then it lands on the wet paint, and you end up with all of these balls of paint on the surface and a terrible finish. Now you can avoid this to some extent by turning down the paint and the air, but I find that it still happens, and even if it happens a little bit, it really takes from the finish. So I can now rivet this part of the case back together, and then I just need to wait on the airbrushing. The airbrushing is now complete. You'll notice that what I've done with the lightning, I've gone for an animated look instead of a realistic look. And there's a number of reasons I did this. One of the reasons is I wanted to stick to the color scheme of the build. Obviously I have added one extra color, which is white, and actually originally the client requested purple lightning, but we decided against this because I wanted the lightning to have some definition. If it was purple, it would have blended into the silver background. It would have been a lot more subtle, and the white gives it at least a hint of realism. But if we went for full realism, it would have needed more layers and more colors, some blues, and even clouds in the background. And the other thing it would have needed is a lot less lightning. There's a lot of lightning here, a lot of detail, which makes it look a little bit unrealistic. It's also very thick lightning, and the reason I did both of these things, or decided on both of these things, is because I wanted the lightning to really stand out. Once the build is complete, the components will stand out more than anything. There's a nice big side panel window, so I wanted the lightning to match up to the components in detail. I wanted the lightning to be as detailed as the build itself. So you can see the finish is excellent, particularly on this panel. On the rear side panel, it is still a little bit rough, but I'll probably go over that with 2000 grit and then polish it. None of these panels have actually been polished yet. But it turns out there is a big problem with the airbrushing, and it's going to take a lot of effort to repair. And it's a very simple problem. The lightning doesn't line up properly across the panels, and you can see the thicknesses don't really line up either. And some of you are going to be thinking, why didn't I have the airbrushing done, or even all of the painting, do all of the painting with the case fully assembled? And that is possible, but it's definitely not a great way of doing things. Overspray is the biggest problem. Even if you go to a massive amount of effort to mask everything up, you still end up with overspray in places that you don't want it. And also you fill up the gaps between the panels, particularly with clear coat. The panels end up, sticking together. There's a lot of problems to contend with if you do that, so you definitely need to paint the panels individually. And there's a lot of ways of lining up the art. You can measure things out. You can sit the panels next to each other when you're painting. There's a lot of ways to avoid this kind of mistake. But I'm now going to need to go back and repaint some of these panels with the silver, the shadow silver, and then I'm going to need to have some of the airbrushing done again. So I'm going to come back to the custom paint. In the meantime, I'm going to go to work on other parts of the build. You can see that I've assembled the inner steel frame of the case. I'm also going to give you a more detailed look at some of the components, starting with the fans and radiators. For the radiator fans in this build, I'm going to use Noise Blocker Black Silent Pro PL2s. There's actually going to be no case fans in this build. Now, I've used Noise Blocker fans in almost all of my builds recently, and there's a number of reasons for this. I really like the look of these fans, and because of their subtle aesthetics, they suit almost any build. But it's mainly the specifications that I'm after, and Noise Blocker also make very quiet fans. At 1400 RPM, 1.269mm H2O, 56.5 CFM, and 20 decibels, they make an excellent radiator fan for silent configurations, and I even use them on Black Ice GTS radiators, which have a fin density of 30 FPI. Now, you don't often see me using XSPC radiators, but recently XSPC has expanded their range of radiators and they've also improved their quality. And I really like the look of the EX range. This is an excellent looking radiator, mainly thanks to the outer 3mm thick aluminium frame, and it makes them an extremely robust radiator. With the larger thread size, there's a lot less chance of stripping the threads. They have a 16 FPI with a split fin array, so per channel per inch there's actually 32 fins. Split fin array is an excellent idea. It makes the fin array a lot more dense but still allows for good airflow. And these radiators are 40mm thick. They have a brass and copper core, so the fluid path is entirely copper and brass. The aluminium is only in the outer frame. Now, I've talked about radiator thread sizes a number of times previously. Most radiators have thread sizes of M3, also 632. Not many radiators have a thread size of M4. And that's why I like to use black ice radiators. That's one of the reasons, because they have M4 threads. The reason I prefer M4 threads is actually a number of different reasons. The thread is stronger, more difficult to strip. That's not going to be a problem with these radiators though, because these radiators have far longer threads because of the 3mm aluminium frame. But I also prefer M4 threads because I like the look of the larger bolt heads, and most cases are actually designed for M4 bolts or larger. Because of the size of the mounting holes, if you use anything smaller, the bolt heads are almost falling through the mounting holes even with washers, and the strength is not that great. So I'm now tapping out the threads to M4. And I'm going to do that to all of the threads on both of these radiators. So the first thing I'm doing is drilling out the holes to size, and then I will tap the threads. And it's very quick and easy to do. One thing you should be aware of if you're going to do this, you should preferably use a drill press because it gives you a lot of depth control. And the biggest risk here is going too deep and puncturing the radiator, and that is very easy to do with a hand drill. Now moving on to a look at the Asus Crosshair 5 Formula Z. This is an AMD motherboard. It has socket AM3+, the 990FX chipset, and the SB950 Southbridge. Starting in the top left-hand corner, we have an 8-pin EPS, moving across a 4-pin ATX, 3 4-pin PWM fan headers, LED poster, and moving down the right-hand side of the motherboard, a start and reset button, go button, another 4-pin fan header, the 24-pin motherboard power connector, and next to that is some voltage read points and diagnostic LEDs. Moving down, we have a front panel USB 3 header, 8 SATA 3 ports, 6 of them run off the SB950 chipset and 2 of them from an ASMedia controller. This motherboard has an 8+ 2-phase power design, 2 phases for the memory. This motherboard can take up to 32 gigabytes of 2400 megahertz memory. It has 4 PCI Express 2x16 slots, which run at x16 x 8 x 8 x 4, and 2 PCI Express 2x1 slots. So this motherboard can take up to 3 discrete graphics cards in Crossfire X or SLI. Moving across the bottom of the motherboard, we have a further 3 PWM fan headers, 2 front panel USB 2 headers, and a front panel audio header. This motherboard has a total of 8 PWM fan headers. There's another one up next to the Molex Easy Plug, which gives extra power to the PCI Express slots. It also has 3 temperature sensor headers and high quality 8-channel audio. On the back I/O, we have a PS2 port, 8 SATA 2 ports for a total of 12 on this motherboard, which all run off the Southbridge. SPDIF, 4 SATA 3 for a total of 6, which all run off an ASMedia controller. Clear CMOS, ROG Connect, a further 2 SATA 3, which also run off an ASMedia controller, Gigabit LAN, and 8-channel audio. I'm now going to move on to the installation of the motherboard Waterblock. Now, I wanted to use all EK CSQ nickel plexi clean water blocks in this build, but that option was not available for this motherboard. It seems there's only 2 water blocks for this motherboard. This one, which is the EK CSQ nickel acetal, and there is also a copper acetyl version of this water block. So I've installed the motherboard water block, and it's a great looking block. It suits this motherboard nicely, and I'm now going to move on to the installation of the CPU, the AMD FX 8350, and the CPU water block, the EK Supremacy CSQ Nickel Plexi Clean. So I've installed the CPU, and I just wanted to briefly cover what needs to be done to install an EK Supremacy onto an AMD socket. The first thing you need to do is remove the stock hold down system from your motherboard. So there's just 2 screws holding each of these brackets in position, and also some kind of backplate. You then need to swap the Intel hold down plate, which comes installed by default on the EK Supremacy, for the AMD hold down plate. To do this, you need to dismantle the EK Supremacy by undoing the 4 bolts from underneath the water block, and this will give you access to the hold down plate. The most difficult part of all of this is if the O-ring around the outside of the water block falls out of position, and most of the time it is going to. So you need to carefully place the O-ring back into position and make sure that it stays in position as you're reassembling the water block. The EK Supremacy comes with a universal jet plate installed, so you can leave the stock jet plate installed because it is also for AMD CPUs. It is possible that EK may change this at some point, so also make sure that you closely follow your installation guide. So I've now installed the CPU water block, and I'm going to move on to the installation of the memory and memory water block. So now looking at the 32GB kit of Corsair Vengeance Pro memory. It runs at 1600 MHz, 99924 1.5 volts. I really like the look of this memory. I think it's a big improvement over the original Corsair Vengeance. In my opinion, the main improvement is the black PCBs on the memory modules, but I also like the look of the heatsinks. And these heatsinks are fairly easy to remove. There's no bolts or anything holding them together, but adhesive thermal interface material has been used, and the best way to remove these heatsinks is with a heat gun. Just lightly heat the memory modules and the heatsinks will be a lot easier to remove. So this is the EK Monarch module adapters, and this is just a heatsink for any memory, as long as you can remove the stock heatsinks from any DDR3 memory. You can install the EK Monarch module adapters, which then allow you to install the EK Monarch memory water block. So you can see I have another top here for this water block. So this is an EK Monarch CSQ Plexi water block, but I'm going to swap the top to the EK CSQ Clean Plexi. And I really like the look of EK CSQ Clean blocks. I just think it's, well, really I think they're some of the best looking water blocks that EK has ever made. And I'm so glad that after the release of the CSQ design, EK had the sense to listen to the community, their consumers, and release some of the components that the consumers wanted. And if you would like to go and have some input on the components that EK releases, check out the link in the video description to EK's ThinkCell. So I've now installed the CPU and memory, and also the CPU and memory water blocks, as well as the motherboard water block. So for those of you who didn't know, you can see how the EK Monarch module adapters work. There's just 2 sides which bolt together onto the memory modules, and there's also TIM that needs to be installed, and then there's a good flat surface on the top for the EK Monarch memory water block to make contact with. There is a problem that I've had with, well, just about every time I install EK Monarch module adapters, at least one of the threads is already stripped. So this is a problem that EK really needs to resolve. Now moving on to a look at the MSI 7970s and the EK 7970 water blocks. MSI makes some great looking graphics card coolers, and they usually perform substantially better than the stock cooler. They have improved temperatures and they're also quieter. MSI makes some excellent overclocking graphics cards, for example, the Hawk and Lightning series, and they're usually very well priced. This cooler has a Unisync, which helps to improve the strength of the graphics card, which can help to prevent damage, and also stop the graphics card from sagging once it's installed. Personally, I prefer closed graphics card coolers just because of the cleaner aesthetics, but with something like this, theoretically, you are going to get better airflow and therefore better performance. But obviously the problem with this design is it puts hot air out into the case. So these graphics cards have brown PCBs, but that's not going to be a problem because I am going to be installing backplates onto these graphics cards. I am still waiting for the backplates to arrive, but I'm still going to go ahead with the Waterblock installations because there's really not much I can do on this build at this point because I'm still waiting for the airbrushing to be repaired. So in the meantime, I'm just going to do as much as I can. So you can see, again, these water blocks are different from the rest of the water blocks in the build. The CPU and memory water blocks are CSQ nickel plexi clean, the motherboard water block is CSQ nickel acetal, and these water blocks are CSQ nickel plexi. But the difference between the water blocks is not that extreme, and the only water blocks that are really going to be in full view is the CPU and memory water blocks. The motherboard water block just blends into the background behind a lot of the components, and the graphics card water blocks are obviously going to be face down and almost completely out of sight. The only reason for the difference between the water blocks is because these were the only water blocks available. Around the time EK manufactured water blocks for these components, EK didn't have many options. It was after the release of EK's ThinkCell that EK started to release a lot more options when it comes to aesthetics for their different water blocks. If you take a look at the GTX 780 range, for example, all of the different 780 and Titan water blocks, there is just so many different options when it comes to aesthetics, which is really great to see. So I've now installed the graphics card water blocks, and installing the backplates really won't be a big deal. I'll just have to remove a number of the bolts from the back of the graphics cards that are holding the water blocks in position, install TIM, and bolt the backplates into position. Now for a look at the pump and reservoir. So I have here the Swiftech MCP35X, the BitsPower Acrylic DDC Top, and the BitsPower Acrylic DDC Top Upgrade Kit 250. Now the Swiftech MCP35X has some substantial improvements over any of the other DDC pumps. It has improved overall performance. As you can see, it has a different pump top with G1 quarter-inch threads, and it's also a PWM pump. So this is the pump I always go for my smaller loops. But it's an extremely high performance pump. You can even use this in a high-end loop with a whole lot of components. The main difference between this and a D5 pump is the pressure. This puts out 22 psi, whereas a D5 pump puts out 50 psi. So personally, if I'm using more than a couple of radiators and say 3 water blocks, I'll move up to a D5 pump. Now I've been using this pump top for DDC pumps for a lot of years now, but in the past when I've used this pump top, I've had to use a fitting between the pump top and the reservoir, and I always used to use a mini D-plug. But recently BitsPower has come out with a DDC top upgrade kit, which allows you to mount a BitsPower reservoir directly to the pump top. And you can see that the design is exactly the same as BitsPower's D5 upgrade kit, which they came out with a number of months before this one. So now they have an upgrade kit for both the D5 and DDC, which means you can mount reservoirs directly to both of those pump tops. And it really is a great looking compact configuration. And you know, it also improves performance slightly. Instead of having fittings in between, it's a more of a direct connection. But this is the config I always use in my smaller form factor builds, because you can get right down to an 80mm reservoir for this, which means that it's going to be not that much more than 100 millimeters in height. So there it is, assembled, and you can see that the reservoir looks, fairly large for this config, and I might actually drop down to the bits power 150mm reservoir. I'll just have to wait and see how well this fits into the case. So now coming back to the custom paint, you can see some big changes have been made to the art, and that's because when the panels returned from having the airbrushing repaired, the art was fixed, the lighting lined up across the panels, but I really wasn't happy with the quality. There was some big problems with the finish, and there was also some other problems. So I decided that the only way to get a perfect result was to start again from scratch with a new case. And I didn't use any of the panels from the original case, which would have saved me a lot of time because I didn't want any variation in finish or color. So this is the new case. I've started the painting again from the beginning, and I'm really happy with the result. It was certainly worth all of the extra effort because it was a big decision for me. I knew it was going to take a lot of extra time because I can only hang around 10 panels at once in my workshop currently, which means I need to paint a case like this in parts. And if you consider all of the different coats and the dry time, the time adds up, and it really draws things out. It takes a lot of time. And I'm constantly improving my workshop and purchasing more tools, so hopefully coming up I'll have things set up so that I can do an entire case at once. The other thing I decided this time around was to work with a different artist. And I'm really happy with the art. I've made some big changes to it. It's a lot more subtle, more realistic. There's a lot less lightning. It's a lot thinner, as you can see. And it now extends from one part of the case, which is where the logo is going to be, and it wraps around the case. And it's a single bolt of lightning. And if you imagine it vertical, you can see that it's a really realistic looking bolt of lightning. It's been really well done, and the artist that I'm now working with, he does photorealistic airbrushing, portraits, anything. He does entire cars, some incredible work. So I'm really excited about future builds. But I also think the moral to this story may be that I need to learn how to airbrush myself, which is something I've been wanting to do for a long time. Because I've done a lot of art, I really enjoy it. I've also done a lot of painting. I've painted cars. I do all my own painting now. And I think it's the logical next step. So hopefully within the next few months I can find the time to start doing some experimentation with airbrushing. And soon I can start doing at least some of the airbrushing for my builds. And then I can start doing airbrushing guides, which I think would be a great addition to my channel because it's fairly cheap to get set up for airbrushing. And even if you're not that skilled at it, you're just a beginner, you don't have to do full art pieces. You might just be adding a little bit of weathering or just somehow enhancing your mods, enhancing the theme. There's so much you can do with airbrushing. I think it is a vital part of modding or advanced modding. So you can see I've started installing components. I've installed both of the radiators, all of the fans, the motherboard, and the graphics cards. I still need to remove the graphics cards again to install the backplates, but the build is now up to the point where I can start on the tubing and the custom wiring. So the build is now well underway. And I've actually done a lot of the custom wiring at this point. I have a lot of the cables ready to go. But I'm going to come back to that in the next part of the build log. So that sums up this video. Thanks for watching. Please subscribe, like, and favorite if you want to see more.